In this video we'll get an expression for torque in the polar coordinate system. In the previous video we obtained torque is equal to x Fy minus y Fx. Right? In this we'll look at the polar coordinate system. So let us say the particle P is at an angular displacement theta at time t, and the force acting on it is F, right? And let us say the angle that the force makes with this particular position vector r of this is, say, for example, phi. Right? So the angle between the direction of the force and the direction of displacement is phi. To calculate torque, I have to take the magnitude of the force and the distance, the perpendicular distance between the line of action of force and the axis of rotation. We know this is the axis of rotation, so there's a perpendicular line going into the plane of the page of this paper, and this is the line of action of force. I'll draw the line of action of force over here. Right? So this is the line of action of force. Right? So what is the shortest distance between the axis of rotation and the line of action of force? As you can very clearly see, this is what it will turn out to be. This is the shortest distance. This is the shortest distance. Let us call this t. This is the shortest distance between the line of action of force and the axis of rotation. So if I get the product of the force and this particular distance, then I'll get torque. So torque will be equal to F into d. Right? The magnitude will be F into d. What is t? What is the magnitude of d? If this is phi, this turns out to be phi, and if I take sine phi is equal to opposite side, that is t upon, this is perpendicular upon hypotenuse, and hypotenuse is r, so therefore d is equal to r sine phi. And if I put this value of d in this equation of torque, I get torque is equal to f r sine phi. Right? So I have got an expression of torque in terms of the polar coordinates fr sine phi. And there is another way of looking at this particular derivation or equation, and that is we can have two components of the force, right? So I can have two components of the force, right? So I'll try to get those two components, right? So let us say these are the two components of the force. One component is this, right? And this is the another component, right? So these are the two components of the force. I will call this F R, and I'll call this F theta. R because it is radial, right, directed towards the center of the circle, and this is in the direction of rotation, of angular rotation, therefore F theta. Right? So F theta and F are the two components of the force F. As you can very clearly see, F theta is responsible for the rotational motion. Fr is acting along the displacement, along the line of along the axis of rotation. So this will not cause any torque because the distance between Fr and the axis of rotation is 0, right? They're acting on the same point. So there's no torque being applied by Fr because the line of they're acting on the same line. The rotational motion is caused by F theta. So I have to take F theta and the distance between this axis of rotation. So if I take the distance between F theta and axis of rotation, then again I'll come back to the equation of let me get values of Fr. Fr will be equal to F cos phi. Right? Fr will be equal to cos phi because this is phi, and F theta is equal to F sin phi. Right? As you can clearly see in this particular triangle, this is phi. Sin phi will be F theta upon F, and cos phi will be Fr upon F. So F theta will be F sin phi, and Fr is equal to F sin. Right? So this is how I get, and from if I use this, if I go back to this equation, tau is equal to F r sin phi, then F sin phi is F theta, so F theta into r, right? This is another expression for torque. What I have done is I have substituted the value of F sin phi as F theta. F sin phi is F theta, so tau is equal to r F theta, and this very clearly indicates that it is the F theta is responsible for torque. So F theta, which is the radial component, is responsible for torque. Right. And once again, going back to the equation of tau is equal to F r sin phi, right? tau will be maximum when r is maximum, right? So larger the value of r, will get more torque, and when sine phi is maximum. So these are the two conditions under which torque can be maximum for a given value of force. The larger the value of r, will get maximum value of torque, and larger the value of sine phi, more torque. So it's directly kind of proportional to this, and that means phi should be equal to 90 degree for maximum torque. That means the same diagram I draw over here, right? This is y-axis, this is x-axis, and so let's say this is r and this is point B. Then if I want maximum torque, then the angle between force and r should be 90 degrees, so that we are able to get maximum torque. Okay, so we have looked at expression for torque in polar coordinate system, and in the next video we will look at the rectangular components of torque. Thank you.